Let's find the derivative of inverse sine of x, and then we'll kind of use that logic. We're not going to go through all 6 of them in this lesson, but if we can at least see the logic once, we'll kind of understand where things are coming from. So let's take a look at the function y equals the inverse sine of x, and the question that we have in front of us now is how can we find dy dx, the derivative of y with respect to x. And so what I want to do is I just want to differentiate both sides with respect to x, and that's really what I'm curious with over here on the right side. Well, I don't really know how to do that right now, but I have some understanding of inverse functions, and so let's see if we can't rewrite this in a way that's going to allow us to do this. So I can say because y equals the inverse sine of x is the inverse of y equals the sine of x. And then just by definition, this function right here is the inverse of this function. Well, if I have this function and want to know its inverse, I just take the x's and the y's and swap them. That means that x is equal to the sine of y. And so this, I can kind of take the derivative of with respect to x of both sides. I know how to do that for sure with x, and implicitly I can figure out how to do that with the sine of y over here. Another way to think about it, if I come over here and I take the sine of both sides, I get the sine of y, which is what I have on this side of the equation. And if I take the sine of the inverse sine, again, those are inverse operators, they would undo each other. I would be left with x. So let's take a look at x equals sine of y, which is going to have this exact same equivalence as this right here. I know how to take the derivative of, with respect to x of both sides of that though. So let's take the derivative with respect to x of x, and let's set it equal to the derivative with respect to x of the sine of y. Well, over here on the left side, that's just equal to 1. The derivative of the sine of y with respect to x, I take the derivative with respect to y, which is going to be cosine of y, times the derivative of y with respect to x. If you take a look at what we were trying to find, it's now there. So let's solve for dy dx. It's 1 over the cosine of y. Now before you go off and say that's the secant of y, I'm actually going to pause you right there. This is in terms of y. I would really like to express the derivative in terms of x. So let's see if we can't use some of our understanding of trig to get the cosine of y to instead be a function of x. So I'm going to use a couple of things, so just to kind of, again, express what we're trying to do here. To get the cosine of y in terms of x, we're going to start with the fact that x is equal to the sine of y. That's going to be kind of our key to translate back and forth between y and x. I know the sine of y is equal to x. I'm trying to figure out what the cosine of y is equal to. And in order to do that, I'm going to use kind of our famous trigonometric identity, the Pythagorean identity. I'm going to use the sine squared of y plus the cosine squared of y is equal to 1. Now if I take a look here, I can solve this identity for the cosine of y. So if I subtract the sine squared of y, I get the cosine squared of y is equal to 1 minus sine squared of y. And then I would take the square root of both sides, and so I get the cosine of y is equal to the square root of 1 minus sine squared of y. Now that I'm really close here, I've got cosine of y equals. I want to make this substitution into here, but I need to get it back into terms of x. Sine of y is equal to x. That means that the sine of y quantity squared is equal to x squared. So I know that the cosine of y in terms of x is equal to the square root of 1 minus x squared. And that's what I actually want to substitute in here. So I can say the derivative of y with respect to x is 1 over the square root of 1 minus x squared. And that is the derivative of the arc sine or the inverse sine of x. When we look at it here in a second, we're going to go ahead and lay all 6 of them out in the next video. We're also going to make sure we want to understand that sometimes we're going to take the derivative of the inverse sine of x, and sometimes we might take the derivative of the inverse sine of a function of x. So this is the derivative of arc sine of x, And in the next video, we're going to kind of formalize our thinking and start to kind of bring in the chain rule into the mix as well and give you the derivatives of all 6 inverse trig functions.